There's never been a better time to be building the future. Better connectivity technology that can scale to the entire planet, bringing billions of people online to a faster internet. Nothing in the world is advancing as fast as AI is today. And it's helping us build entirely new computing platforms. From VR headsets to AR glasses. These new platforms will help us share truly immersive experiences and reimagine what it's like to be together, even when we're physically apart. Transforming how we work, play, and connect with the people we care most about. We build these new platforms and technologies with privacy and safety baked in from the very beginning. And it's all being invented here, inside the lab.
Hey everyone, and thanks for joining us for Inside the Lab. We work on a lot of different technologies here at Meta, everything from virtual reality to designing our own data centers. And we are particularly focused on foundational technologies that can make entirely new things possible. And today, we're going to focus on perhaps the most important foundational technology of our time, artificial intelligence. We're going to share some breakthroughs in our AI research and some of the problems that we need to solve as we build for the metaverse. The kinds of experiences that you'll have in the metaverse are beyond what is possible today. It's an immersive version of the internet. Instead of just looking at something on a screen, you're going to actually feel like you're inside it or right there present with another person. And that's going to require advances across a whole range of areas, from new hardware devices to software for building and exploring worlds. And the key to unlocking a lot of these is advances in AI. So let's take a look at some of the challenges that we're working on. First, creating a new generation of assistants that will help us explore new worlds. Today, a lot of AI research is focused on understanding the physical world. But in the metaverse, we're going to need AI that is built around helping people navigate virtual worlds as well as our physical world with augmented reality. And because these worlds will be dynamic and always changing, AI is going to need to be able to understand context and learn in the way that humans do. And when we have glasses on our faces, that will be the first time that an AI system will be able to really see the world from our perspective, see what we see, hear what we hear, and more. So the ability and expectation that we have for AI systems is going to be much higher. Now, we are already using simpler machine learning systems to parse information for us today. Every time you get a recommendation or search for something or even take a photo on a phone, there is machine learning in the background. Computing is also becoming increasingly contextual. Instead of this static experience that's the same no matter where you are, the way that we use computers now adapts much more to what you're doing. And as devices have gotten better at understanding and anticipating what we want, they've also gotten more useful. Now, I expect that these trends will only increase in the future. The metaverse will consist of immersive worlds that you can create and interact with all the visual information that includes, like your position in 3D space, your body language, facial gestures, and so on. And this is all from your first-person perspective. So you experience it and move through it as if you are really there. And all that adds up to a lot more input to be processed and a lot more content to be generated. So we're going to need help navigating all of this efficiently. And the work that we do to build this is going to pave the way for assistants that can move between virtual and physical worlds too. A key part of this effort is building better models for richer and deeper communication between people and AI. So today, we are announcing Project Karaoke, which is a fully end-to-end neural model for building on-device assistants. It combines the approach behind Builderbot with the latest in conversational AI to deliver better dialogue capabilities. And from there, to support true world creation and exploration, we need to advance well beyond the current state-of-the-art for smart assistants. So we're working on two areas of AI research to make this possible. egocentric perception, which is about seeing worlds from a first-person perspective, and a whole new class of generative AI models that help you create anything that you can imagine. Now, here's an AI concept that we created called Builderbot, which showcases this work. It enables you to describe a world, and then it will generate aspects of that world for you. So let's take a look at how this works. Hey, Builderbot. First, let's start with the scene. Let's go to a park. Actually, let's go to the beach. Pretty good. Let's add some clouds. Huh, that's all AI generated. Actually, let's add some alto cumulus clouds. All right. And let's add an island over there.
It's cool. How about we add some trees out here by the sand? Let's get a picnic blanket down here. Let's put up a table. Let's put a stereo. Let's get some drinks as well. Let's get the sound of some waves and seagulls.
Does that speaker work? Let's play some tropical music. And let's add a hydrofoil. You gotta have a hydrofoil.
You gotta teach me how to ride one in VR.
All right, that's pretty good, right? Now, as we advance this technology further, you're going to be able to create nuanced worlds to explore and share experiences with others with just your voice. But there are a lot of challenges that we still need to solve to get there. One is developing true multimodal AI. A lot of the early AI work has been focused on text. When you have a clearly defined syntax, a finite set of input words, and a lot of easily available training data, predicting how a sentence might end can be relatively straightforward. But if you only have 10 or 20% of an image, predicting what the complete image will show is a lot more difficult. And figuring out what scene in a video will come next is another step change in complexity. So now imagine going beyond video to fully immersive experiences. What will it take for AI to accurately interpret and predict the kind of interactions that will happen in the metaverse, where people are moving between physical and virtual spaces and creating all kinds of new worlds? The main way that we have approached this is by working on self-supervised learning. Now, before SSL, most AI systems were trained with supervised learning. That means that you feed them lots of labeled data, say 100,000 images of cats, and explicitly tell them this is a cat, this isn't a cat, until they recognize some patterns. But Jan LeCun, our chief AI scientist, believed that this wasn't going to be enough to produce systems that can really understand the world. So we made a big bet on self-supervised learning. And the idea here is that you don't teach the AI any specific concepts. You just give it raw data and ask it to predict the missing parts, and it will learn abstract representations along the way. And this actually seems closer to how the brain learns. For example, you don't need to show a kid thousands of pictures of a cat for them to understand what a cat is. Now, this has become the primary method of training AI to understand natural text, and it is now achieving state-of-the-art results for images, speech, and other types of data too. In fact, self-supervised learning now outperforms many other existing methods for images and video, even models that rely on millions of labels, which is a huge step forward. And while self-supervised learning is still developing, we think that it's going to be an important tool for the metaverse, because the complexity and diversity of the environments that people will experience in AR and VR will be too great to be captured with labeled datasets. Traditional computer vision techniques also aren't going to be enough to support that real sense of presence and interaction that will define the metaverse. So to help advance the state of the art in systems that can see and understand the world like we do, we recently brought together a global consortium of 13 universities and labs to work on Ego 4D, the largest ever egocentric dataset with thousands of hours of first-person video and benchmark tasks that everyone can use to research and build. So if you're working in this space, I highly encourage you to check this out. Now, the big goal here is to build a universal model that can incorporate knowledge across all modalities: text, speech, movement, position, body language, all the information that is captured through rich sensors. This will enable a vast scale of predictions, decisions, and generation, the fundamental processes of how AI systems learn, as well as whole new architectures, training methods, and algorithms that can learn from a vast and diverse range of different inputs. Now, this is a major challenge and one of the critical steps on the path towards true AI. But before we get there, AI can help us solve an even more fundamental problem. And that is, even while access to technology is expanding globally, still nearly half the world can't access the internet in their own language. Now, this is partially because most of the web is in just a handful of languages. For example, there are millions of people who speak Fula in West and Central Africa, but their language is almost non-existent online. This is also because even the most advanced AI models used for translations today were often trained in English. So a lot of services would translate something from a source language into English and then from English into the destination language, which adds some noise and imprecision to the translation. So we built and open sourced an AI model that can translate directly between 100 languages without having to go through English as an intermediate step. We're going to keep building technology that enables more people to access the internet in their language. And in the future, we hope to extend that to content and experiences in the metaverse too. This is going to be especially important when people begin teleporting across virtual worlds and experiencing things with people from different backgrounds. Now, we have the chance to improve the internet and set a new standard where we can all communicate with one another, no matter what language we speak or where we come from. And if we get this right, this is just one example of how AI can help bring people together on a global scale. So to do this, today we are announcing two new projects. The first is No Language Left Behind, a new translation system that can learn every language, even if there isn't a lot of text available to learn from. We are creating a single model that can translate hundreds of languages with state-of-the-art results in most of the language pairs, everything from Asturian to Luganda to Urdu. Now, 5 years ago, we could translate across a dozen languages. 3 years ago, we were up to 30 languages. And this year, we are now aiming for hundreds of languages. The second project is even more ambitious, a universal speech translator. The goal here is instantaneous speech-to-speech translation across all languages, even those that are mostly spoken. The ability to communicate with anyone in any language, that's a superpower that people have dreamed of forever. And AI is going to deliver that within our lifetimes. Now, you're going to hear a lot more about these efforts from Angela, who's one of our AI researchers who's driving these breakthrough advancements in translation. But before I hand over to the team, I want to say a few words about the way that we approach this work. And we're clearly focused on building technology to help people feel closer in all kinds of new ways. Right? That's our DNA as a company. Most tech companies focus on building new ways for you to interact with technology. But we build new technology so you can interact with the people you care about. One great thing about fundamental research is that advances made to help us achieve our vision also have wide-ranging applications to enable completely new things in other areas as well. One example of this is FastMRI. It's a project that uses our AI to cut the amount of data that an MRI scan requires by 4x. So if you've ever been in an MRI scanner, you know that reducing the time spent in the scanner by 75% is a really big deal, especially for kids who struggle to stay still for an hour. It's rare to get that magnitude of improvement by bringing an unrelated technology to an existing problem. It's kind of like, if you invented a new kind of energy that was suddenly 75% more efficient and, being able to use it to power all sorts of things. So I think that we're at a very exciting stage in this cycle, and that definitely motivates us to try to enable this kind of innovation as much as possible. We're also driven by long-term goals. We can do this metaverse work today because of the long-term investments that we started making in AI and virtual reality starting almost a decade ago. And the breakthroughs that we're now seeing in AI are thanks to long-term bets in self-supervised learning that we made in the early days of our research labs. And we're committed to building openly and responsibly. As we make progress on this journey, we have the opportunity to build better, safer online environments for all of us. And that means creating AI technologies that deliver the highest levels of privacy and help prevent harm, like Crypt10, a framework for privacy-preserving machine learning that we built and open sourced. And it also means engaging with human rights, civil rights, disability rights, and privacy experts, and building systems grounded in fairness, respect, and human dignity. And it means working openly and sharing progress, and also building the metaverse for everyone, so that people around the world have access to tools and technologies to realize their own vision for the future. You're going to hear more about our commitment to open science and responsible innovation shortly. But now, it's time for me to turn things over to Jerome and Joelle.